Hi everyone, Shane Crossman from Geoscience Australia. It's great to be here in Vancouver. ELVIS is a project that we started around about 18 months ago, and it was to replace a elevation portal that needed replacing. It's a very simple tool in the sense of the interface itself. We only allow 4 products to be distributed from it. I won't do a live demo just due to time, but it has 4 products. They are basically set up parameters. The way the tool works is that you select an area across Australia with the data set that you're interested in. It creates a bounding box. That bounding box intersects. The bounding box is created, and then we create you're able to select coordinate systems or formats. And then you send your email, and then that information is passed back to FME, and that interacts with a tile index, which then collects data from an Amazon S3 bucket, and then it gets delivered to you. We released ELVIS in March of 2016, and the idea around it was that we wanted to make sure that it was open, it was free and accessible. It needed to be quick delivery, and they were really our main points. There were a few others there that we like to do, but it all fell under what we would call a Foundation Spatial Data Framework. And the Foundation Spatial Data Framework was developed by the Australian Spatial Council, or ANZLIC, and its role was really to identify the core data sets that would underpin Australian decision making, and particularly to encourage prosperity for the nation. Elevation and depth is one of those 10 key themes, which is where ELVIS fell in under. I just want to take you back a little bit about our data sets. We've been delivering elevation data for a long time, and we had a thing called the NETF portal, and this was the portal which I was asked to replace. The NETF is a key framework for Australia in the sense that it was designed to be a federated model, and the idea of this portal was that there would be nodes across each of the jurisdictions and our regional areas, and each jurisdiction would be able to share information without having to necessarily collate it in the one spot. It sort of didn't work, and I'll explain that shortly. Between 2014 and 2015, though, we had a very big jump in our amount of orders, more than doubled, which you'd have to say that's fairly successful. But I was charged with killing it, which is probably not the nicest thing to say about something that's been quite successful. Decommissioning is probably a better way of putting it. But the reason why we wanted to do that was that the technology that had been built on was getting rather outdated. Many of the components that delivered the data as part of the application were no longer compliant. So from an ICT perspective, trying to embed that back into core business was almost impossible. Hence, we had to continue to get an external provider to keep maintaining it. So we had to make a decision on whether or not we were going to continue to support a software code-based portal or jump into the world of our cloud-based infrastructure. My job was to convince our ICT group that the cloud-based infrastructure was the better way to go. And a key role of that was that I wanted to automate our delivery. During 2016, after automating the delivery, of which we called ELVIS, our orders jumped from 2,600 to 12,600. An important thing to note in this is that ELVIS only delivers 4 of our products. A very small subset of actually all of the data we actually have is open data. In some regards, we probably simplified what the users wanted, but a key component was that we were only going to deliver our open data, and our restricted information we would keep in our corporate data stores and handle them manually. The platform that we chose as part of our cloud infrastructure obviously included FME Cloud, Amazon, and we have ELVIS itself is an in-base web application tool. I'd like to talk a bit about costings. And, sorry, I'll go back a slide. Whoops. I'll go back to this slide for a second. In and around costings, the old tool that we had, we would spend close to $500,000 of putting staff onto delivering elevation data each year. We would then spend another $250,000 on the infrastructure to support that. A key thing which we would like to do is to obviously reduce those costs. ELVIS, it cost us $40,000 to set up the actual interface, and we've spent probably around about another $100,000 actually implementing it. The infrastructure costs are very minimal. The FME server is costing us around about 25,000 Australian dollars per year, and the delivery costs are costing me about $800 a month. Anyone who delivers elevation data would probably know the pains of having to transfer data onto USB drives and then charge the USB drives to people. Shifting 1 to 14 terabytes of data onto USB is not an easy thing to do, let alone trying to recover the costs of delivering it. So $800 a month for me to deliver essentially around about 1,200 orders basically saved a whole lot of time and a whole lot of effort. And it also, from a cost perspective, 3 hard drives is $800, which would only satisfy maybe 1 to 2 users. So essentially what we've created is a factory, a warehouse and a cafe. And these are the components that we've made up with those. Amazon's our warehouse, FME is our factory. It's where we define everything that we want to do. It's the workflows, the workbenches, the product descriptions, how we want to manipulate the information, how we want to deliver it through an email system, etc., etc. And the cafe is our access points. We can have many of these if we really wanted to. We have a term in Australia called YAPs. I don't know if people know what YAPs are, but yet another portal. But these could pop up everywhere. The fact that it's open-based code, people can take this information and create their own portals of this same information and replicate it over and over again. A key thing which we wanted to be able to deliver as Australian government was that we're quite happy for people to reuse the data. We just want to make sure that they're using the same data. And they're all interchangeable. So why FME Cloud? There's a couple of reasons. I mean, one, the ETL is very easy. And it's very easy for me to pull in staff and to train them up very quickly on how to use it. It's simplicity, even though it can get quite complex, its simplicity in being able to start is easy to transfer. And this was a key thing of not just convincing my own ICT department about implementing FME Cloud and going down this path, but there is also a cultural change between the actual workers and staff inside the organisation on what they're comfortable in doing. So there's been a period of change where we've had to go through and update skills to actually work in this environment. 2 years ago, no one in my team would have been using FME or FME server. The first person that I brought into the group that actually had some FME skills was Rob Kay, and that was around about a little bit under 2 years ago from now. It's flexible and it's scalable, which everyone knows about. In the sense of being able to create workflows, that's fairly a common thing, and I know everyone's been flooded with this type of stuff all the last couple of days, so I'm not going to try and work my way through. But what became useful for us was particularly around the job handling of the information, particularly if we're dealing with hundreds of records each day and processing large amounts of data. We move around about 8 terabytes of zipped up LAS or DEM data each month. The other advantage that we found with FME Cloud was that we were able to embed that with our S3 in our EC2 bucket, and the transfer of data between the two is cost neutral. It's zero cost. It's also very, very good in the sense that it does a lot of things like notifications and dashboards is very handy. It's job handling, as I just mentioned, and it's streaming. All valuable things for us to be able to do our analytics and move our information around. We create lots of workspaces. We have defined parameters. We do lots of data analytics. And I only just found out in Brett Madison's previous talk that a lot of the data analytics that we are developing here in the way that it's being published actually came out of a hackathon in February last year. But we do lots of things, and managers and things love this type of stuff. If you're able to represent your data on how to be able to define impact, they love graphs, they love things. The image that I like probably the best from our analytics is the map and all of the bounding box of where people have been able to download data. And if I really want to, I can actually interrogate each one of those boxes and pull information out on who's downloaded it, where's it been downloaded for, what formats, what coordinate systems. It's a very powerful bit of information. And like all things with FME, you can modify the things to be able to report in different ways. And we've got different ways which we work with our jurisdictions. So sometimes we combine all of the reports, we provide specialised reports for New South Wales Government, and we have our own, I won't necessarily open them all up. A key part of what we also wanted to do was not only to get people and users to use the same data, but one of the things which we wanted to fix from the NEDF portal was actually how we can communicate with the jurisdictions and share the same infrastructure, which was the original idea of the NEDF portal. And the New South Wales Government got on board and decided that they would like to utilise our infrastructure and upload their data, as long as they could control their information and their data, so they had their own S3 bucket. We then linked the interfaces to that S3 bucket and through our FME cloud, and they were able to republish a new portal. A key component, though, that they needed to maintain, which was slightly different to what we had managed before, was, and it got spoken a little bit in Brett Madison's talk, was around provenance. They wanted to be ensured that if GA was releasing this type of information, that people didn't get confused that it was GA's data. We solved that by simply having the data in separate S3 buckets and being able to call the metadata catalogues of both organisations, and we're able to link that information up. A key thing that we needed to change, though, in the sense of looking at standard parameters, which was set up for ELVIS and the way it interacted with FME, was that we started to develop JSON. And JSON was very useful when we came to the terms of having multiple buckets and multiple users. It's very easy when you control your own bucket of information and you can set up and you go, I'm going to update the data today, and that means that I've got to republish services and et cetera, and deploy. When you don't know when someone's going to update data or have data stored there and they're using different indexes, it becomes a bit more of a challenge when you're trying to provide the service and making sure that the users can interact with it. What we found was by using JSON was that we were able to recall on all of those indexes and be able to publish within the tile selection frame of the portal, and it would only query back the information that exists there. And that was the same with our posts. And you can see in here that we've actually embedded in the JSON files, the zip files there from the work packages. The architecture itself is relatively simple. We have multiple buckets in S3 for each of the jurisdictions. We have also a results bucket in S3. FME interacts with those buckets through indexes, so there are multiple indexes that are underlying. They are all individual of one another. Before people say, do they actually nest into? No, they don't. We have 1 metre indexes, 2 metre indexes. We have work package indexes, which can be up to 16,000 square kilometres in size. We have state boundaries. We have things that are occurring along the coastlines. None of it's consistent. But this is where FME has become very useful in being able to coordinate and disseminate that information and aggregate. We use a domino table to record all of our transactions. So as the requests come into FME, they get published into a domino table and get stored in Amazon. That includes everything from when the job started, finished, email addresses, the bounding extents of the request, the size of the data that was created, a job number, and this is important for us to be able to control, because so often we're not able to go back and look at what is it that we did in the year and how much information did we actually pass on. A key activity for myself is that I'm not trying to get money out of people to use my data, so I need to prove, is it important to actually distribute? So I'm more or less trying to get appropriation or funding from government to continue using the service. We use FME is obviously our transformers, and it translates and builds data. It also creates our email address, email notifications, and publishes them back into Amazon to deliver. A key component, though, which I was always interested in, is how do we automate the delivery? And as I mentioned, we've now got multiple buckets that we're trying to maintain, but we don't actually have control over in trying to deliver through a service. And what we're using FME for is to put watches on those buckets, and basically those watches, when they identify changes in those buckets, it sends off notifications. And those notifications then send updates to the indexes and that are associated with those buckets, and it republishes those indexes through services. At the same time it goes through those indexes, it also identifies all the metadata catalogues that are associated to them and rebuilds all of the metadata to be associated with that data. In the case of how much data can we change in one night, it can be up to 50,000 tiles, which happened one time, and we had a little issue with FME in that sense. Our developer just put the watch on the bucket, thought he'd done everything correctly, but what he had actually done is that he made the watch that he would process those 50,000 records through FME at the one time. So what happened was our FME license, FME server basically filled up. Alerts and watches went off everywhere. Brett was sitting in a nice little quiet space, and I got him to give him a phone call to say what's going on. We thought then we had that all fixed up. The next day, the 24-hour watch came over again, and it set off the job again, and that time we got Safe, gave us a bit of a phone call to say what was going on. We fixed all that rather than looking at a bucket and trying to put it all into 50,000 records to being processed all at the one time. It now goes through a couple of records at a time and clears that pretty quickly. The beautiful thing that I like about this is that I can get New South Wales Government to upload their data today. We send a watch off at 11 o'clock tonight. And basically that goes through and runs through this process of recalculating the tiles, linking the metadata, reprocessing the services, and then deploying back to the application. It takes about 20 minutes to do. And the great thing about this is that New South Wales can upload their data, and tomorrow morning that data will be made available to the public. Not everything's going smoothly. We have a bit of work still to do, and particularly in the area of services. We've been trying to publish services through FME, and we're probably getting some performance issues. We probably know why. We don't have any caching on them and various things. We've done it very simply. It's an area which we will improve on, but it's something that has probably caught us a bit off guard. With the need to improve that performance, there are lots of options there for us. We know that we can we've got our data already stored in a PostGIS database. We know that we can put a GIS server over the top of it and put caching. That'll improve the services. We know that we can go into ArcGIS online and then pull those services back into the applications as well and publish. So there's lots of options there for us. We've just got to implement it. but we get lots and lots of hits on our database. Future directions. We don't see this just simply as being for elevation data. Currently, I'm responsible for delivering our surface water data sets for Geoscience Australia, but we're also looking at a GDA 2020 tool. Geoscience Australia is developing a new datum for Australia, and this is going to require a bit of communication with a whole lot of spatial users on how they can transfer their data from GDA 94 to GDA 2020. And what we're looking there is to be able to create a tool where people can take spreadsheets or small data sets, put them into this tool, and then it'll give them back a data set that's been reprojected. SAFE will also be putting these transformers, grids and transformers, is that the right term? Transformations into SAFE. We're also looking at it though for bathymetric data, both onshore and deep shore, and also a whole lot of other topographic layers. It doesn't really matter whether it's line points or polygons or vector. It's all information. It all can be clip zipped and shipped. It's very, very simple, and that's one of the real values I think around FME, is that it can be easily transferred to other things quite easily. I'm always looking at options around all of our state jurisdictions on how we can improve discoverability and access to data. That's a key role of mine. But one of the really big changes that I think will happen in the future is that we won't necessarily be always delivering data. One of the key things which we'll have to do in the future is to look at how we can actually service information to users. A key role for this is always to support decision making, and we know that a lot of our decision makers are very, very limited in their spatial capability. But 90% of their questions is not around I want data, it's around I want an answer for some information that I want. And we're going to have to transfer to that in probably the next couple of years of how we can deliver that and move away from delivering data. Data will always be needed to deliver, but it won't be necessarily our priority. Lastly, we're going to try and make our notifications more public. We've got a stack of options there. We do these things internally, but we haven't yet done them externally. But that's my questions. Do you want to add anything, Brett? No? No? Yeah.
How much data that you have storage in the S3?
In the S3?
Yes.
There's about 8 terabytes of data stored there. We've got, it's all zipped up LAS and point cloud data, so unzipped it's around about 75 terabytes. So
they want to do more, and me being here is holding up the process.
yeah.
A lot of stuff to push up. One of the states.
Yeah. So it's going up. I mean, 3 months ago we were sitting at around about 4 terabytes. So it's going up pretty quickly.
Yeah, to explain that index thing as well, as each LAS file gets uploaded, each LAS in New South Wales data set is a 2 by 2 kilometre tile.
Or 1 by 1.
Or 1 by 1.
Yeah.
As each one gets uploaded, the database index automatically ticks over the status of that file that's available in there as well.
Yeah.
So if you go and use the elevation.fsdf portal and have a look, you go and select the bounding box, the web service Shane was talking about actually comes up and gets a little red tile as you hover over each one in the index, which is what talking about this earlier.
Okay. But how much data have we got to put up there? It's probably close to 400 terabytes in total. So we've got a bit to do. We've got a lot of land to cover.
Great. And what's been the response from the users, like, so far with your project?
Very, very, very good. It's quick and easy. So the delivery times, people get their orders within about 5 minutes, compared to When we were putting things on the drives, it could be anywhere up to 3 weeks. So yeah, very happy.
Great.
And the system hasn't failed once in its 18 months of going. So, yes. It's like, so yeah.
It wasn't a well pre-fixed happening. Yes, there have been a few data failures in the back end, but the way the FME cloud bit's been set up, it spins, and we can actually look in the analytics, we can see the job failures in the analytics as well.
But most of the job fails are around people not putting in their correct email address, or when they've gone to select their area, they've just created a point, so it actually hasn't created a bounding box. That would be 99% of the fails.
Wow.
So,
Too tricky.
yeah.
Great. Thank you, Shane. That was great.